In the previous lesson, we saw a simple example of a recursive function called SUMDIGITS_r. So this function will take any integer and it uses recursion and a stop condition to calculate the sum of all digits of the integer in base 10 representation. So the recursive call and the if condition together, they act like a loop calculation that is repeated to achieve a result. So each execution of the function body is one iteration of the loop. So in fact, this shows we can use recursion to make a loop. This is one of the uses of recursion. And in this lesson, we will go to the root of this intuition. So the root of this intuition will lead us to a technique called invariant programming. So a loop, to define it precisely, is a part of a program that is repeated until a condition is satisfied to achieve a certain result. So loops are an important technique in all programming paradigms they're used. And in fact, loops are a special case of recursion called tail recursion, where the recursive call is the last operation done in the function body. So in this lesson, we are going to give a general technique called invariant programming, which will allow us to program correct and efficient loops. This is very important because loops are actually very tricky things, especially the border conditions. And in many cases, it's very hard to get them exactly right. And invariant programming is an excellent way to make sure your loops are exactly right. And this technique, we introduce it now in the functional paradigm because we're starting with the functional paradigm, but in fact this technique applies for many paradigms, and it applies both for the declarative functional paradigm and the imperative paradigm that we'll see later. Exactly the same technique will apply. So the new concepts that we're going to introduce in this lesson, so in addition to invariance, are the specification of a function. So this is a mathematical formulation of what the function is doing. And then the notion of accumulator, in which the result is calculated. And finally, a useful principle for doing invariant programming, which is called the principle of communicating vases.